Hello and welcome to my circle. Today we'll be discussing the chapter 2 of Fundamentals of Physical Geography, class 11th. We have divided this chapter into two parts, part 1 and part 2, so that to make the entire series more comprehensive. Now before we begin this session, I would like to request all of you to understand the seriousness of present situation regarding COVID-19. This virus is highly contagious and the best way to stop its transmission as of now is social distancing. Please avoid any gathering and try to restrict movement as much as possible. Now let's go back to the chapter, the origin and the evolution of the earth. Let us first see the contents that we are going to discuss in this video. Early theories on origin of earth, modern theories on origin of universe, star formation, planet formation, solar system and formation of moon. So early theories. The early theorists basically focused more on the origin of the earth. So there were two main theories that were put forward, nebular hypothesis and the binary theory. Nebular hypothesis were put forward by German philosopher Immanuel Kant, and it was later revised by Laplace, while as binary theories were put forward by Chamberlain and Moulton. So in nebular hypothesis, what they said that the sun in its youthful stage consists of a cloud, and that cloud later on transformed into the stars. So the cloud associated with the youthful sun got converted into the planet. Sorry. So in the same way, in binary theories, what they said that the sun and there was some other body, star, that came together. I mean, that star came and it struck the sun, and a cigar-shaped body came out of. So the cigar-shaped body came out of because of that wandering star, and as of then that that cigar-shaped body continued to revolve around the sun for some time, and later it got transformed into the planets. So it was the theory. So why it was called binary theory? Because the argument says that there was a sun and a wandering star. So there were two objects existing in a solar space that came together, where stars struck that sun and led to the formation of finally into the planets. And later, for nebular hypothesis, two scholars from Russia and Germany, they revised it, and what they said that the sun basically was associated with some nebula, which mostly consisted of hydrogen and helium and some dust, and they basically came together due to the friction and formed the planets, and they accreted together and they formed the planets. This was the theories. But the modern theorists basically focused on the origin of the universe. So early theorists were focusing on the origin of earth, the modern were focusing on the origin of the universe. So among them, the most renowned theory is Big Bang theory, which we all know. It was given by Edwin Hubble in 1920. What he said about this theory, so this theory is also called as the expanding universe hypothesis. Why they are saying? Because according to this theory, the universe, I mean the galaxies, are continuously expanding, moving far from each other. And the example he made to understand this was of a balloon. But the problem with balloon was that the galaxies itself shown in the dots that were shown on the balloon itself were expanding. But here he said the galaxies are not expanding; only the distance between the different galaxies are expanding. Now the Big Bang theory, what it said that it all began. All the matter, whatever there is, all the matter energy in the universe, it was all in a single tiny ball, and that ball, a singular atom, had an unimaginable volume, infinite temperature and density, that too infinite. So what happened to that? A big bang happened. It exploded so violently at around 13.7 billion years ago from present. The expansion was so big that the matter and the energy got dispersed in the universe. So it was rapid, that's why he called it a bang, and later on this expansion slowed down. Within the 3 minutes that it says, within first 3 minutes of this event, the first atom began to form. So then the temperature got dropped within 3 lakh years from the Big Bang, whatever, like from 13.7 billion years to 3 lakh years. After the 3 lakh years have passed, the temperature got dropped to 4500 Kelvin. So we can understand what would have been the temperature at that time when the Big Bang actually happened. So later on it gave rise to the various galaxies, and various stars got formed, planets formed, and that's what we are going to study further in this video. So this was the concept of Big Bang, that we had a single atom with infinite temperature. It got blasted up, it got exploded, and we got what we got is different galaxies, and they are still expanding. Now another concept that was introduced at that time was Hoyle's concept of steady state. What he said is that whatever is right now, it was from the day first. Nothing has happened. So this concept has not been by the scientific community. However, they don't find any evidence to that, and Big Bang is prominent concept right now that is being upholded. So the star formation. Now we'll move to the next topic of star formation. See, the star formation, before we move to the star formation, I would like you to understand the formation of galaxy. Now the galaxy consists of a large number of stars, that's for sure that you know. It consists of a large number of stars, and the distance between, the average distance between an individual galaxy that you can move from one if you have to cross the entire galaxy, I mean the diameter of the galaxy would be around 80,000 to 1,50,000 light years. So this huge is the galaxy, and there are infinite number of galaxies in the universe. Now this galaxy consists of, how this galaxy got formed first and foremost. See, since when the Big Bang happened, the matter and the energy, they didn't got distributed evenly. So there were some regions where the matter got where the accumulation of matter was more, and this region where there was less. So depending upon the accumulation of matter, the gravitational force got distributed accordingly. Somewhere the density was high and the gravitational force was very high. So now what happened? The galaxy started to form by the accumulation of the hydrogen gas. So what did happen? The hydrogen gas got accumulated in one region, and it led to the formation of the nebula. So we can say the nebula is the beginning of the galaxy. That is the way we can say that. Eventually that nebula grows so, and it forms the clumps of gases, and those become denser and denser, finally giving rise to the formation of stars. Now if we have to explain the formation of star into a more comprehensive way, how we can say? So there is a nebula consisting of the hydrogen gas in a galaxy. Okay, so that nebula, if you can see here on a picture, this is a nebula consisting of a hydrogen gas. So what happens to this nebula? It gets condensed. Okay, not only it gets condensed, what it gets not condensed actually, it gets denser. So there will be the accumulation of it. Okay, how? Because of the gravitation. The gravitation will try to bring it, and there will be this nebula will be swirling around. So the temperature will consistently be built at the center, what we call as a core, and finally when the temperature is immense, the immense heat and pressure will develop at the center, and it will result in the glowing of a star. I mean the star will start burning in the core. The pressure will be immense and the temperature will be immense. So at that time we can see the star has been formed. So we understood the star formation takes place by the accumulation of a nebula, and when it comes closer and closer and closer, the nuclear fusion, the nuclear fusion inside the core happens, and the hydrogen gets converted into the helium. So next topic is planet formation. What happens during the planet formation? See, now we have studied how the star is formed. Now during the formation of the star, now what will happen at the center? Since the immense pressure gets developed, so they will exert the force on the outside gases, dust particles, hydrogen gas, dust particles on the periphery of that star. So what will happen? They will start moving farther and farther from the center of the star. Since they move farther and farther and farther, that material will get that gases and matter force. Since they are moving out, they will get accumulated, they will accrete, so forming a smaller and smaller planetesimals. They will form smaller planetesimals, and these planetesimals further will join together, and there will be a cohesion between them, and finally it will result into the formation of a planet. So now we'll move to our next topic, our solar system. Now the solar system, as of now, we know that we have around 9 planets, and Neptune is the farthest one and Mercury is the closest one. See, this is just a factual information that the solar system, that our solar system consists of the planets. It's about 4.6 billion years ago. It was formed around this. It has 9 planets, our solar system, and 63 moons, and some asteroids, comets, and a huge amount of gases. Now we'll consider the difference between the inner planets and the outer planets. So the inner planets are called terrestrial planets because they resemble like Earth, and the outer planets are called Jovian or gas giant because they resemble like Jupiter. So the difference between them is, first we have to understand the inner planets are smaller compared to the outer planets for a reason, because the inner planets does not have that much of gravity. So they were not able to hold the gas, and further, since they were closer to the sun, what happened, the temperature was very high, and that does not let them to condense the gases. Whereas in outer planets, what happened, the temperature was pretty low compared to the inner ones, and that gas condensed down. Another thing is that since they are far from the parent star, the outer planets, so their atmosphere is very thick. Why is it thick? Because in inner planets the solar winds are very intense, so they blow off lots of the gases and dust from the terrestrial, whereas in outer planets solar wind was not that strong. Again, as I said, the material in the outer planet is very high. I mean, their size is very big compared to the inner ones. That is why the gravitation of outer planets is quite large compared to the inner ones. So, which eventually led them to have a thicker atmosphere compared to the inner ones. Now we'll move towards another topic, that is the moon. The concept of moon was given. I mean, the formation of the moon concept was given by early scientists, and the famous among them was Sir George Darwin. What he said, that the Earth and the moon were together and they were like a dumbbell shaped body, and they were rotating continuously. Then suddenly the moon, this dumbbell shaped body, eventually broke off, and the body that broke off from the main body continued its rotation, and it later formed the moon. But the gap that it left from the parent body finally resulted in the formation of the Pacific Ocean. So this was the early concept, which later on was not held, and today the present-day scientists believe the concept of giant impact or big spat. What they believe, that a body the size having 1 to 3 times of the mass, it came closer to the Earth and have a big spat, as you can see in the picture, and later it moved away. So what happened, a big chunk of the Earth's material was blew off, and it went into the orbit, and it also started rotating like the Earth is. It starts rotating the Earth like the Earth is rotating. So basically they also believe that the moon is the part that is being separated from the Earth because of the spat or a strike that has been that happened at around 4.4 billion years ago. So 4.4 billion years this moon formation takes place, and later on the accretion of that particles that were separated from the moon takes place, and it resulted in the moon, and the solar winds basically shaped the direction, shaped the this circularity of the moon. So this was it for today. Now we'll move to the second part, which will be discussed, wherein we'll be discussing the rest of the chapter. Thanks for watching.